Hi all, this is Tim Olson of Evolution Software. In today's video demonstration, we're going to use PowerPack Pro to convert native SketchUp files into usable solid models suitable for filleting, chamfering, and export to STEP, IGES, and SAT. In this demonstration, we're going to show three things. First, we're going to demonstrate converting two example native SketchUp files into solids. Second, we're going to show some of the options available in a little bit more detail for converting meshes into solids. And third, we're going to look at a few tips for converting files. Let's go ahead and begin our demonstration by importing this native SketchUp file into ViaCAD Pro with PowerPack Pro. And we have a SketchUp file with a bunch of kitchen cabinets that we're going to do our first demonstration with. So we import it, and I have a display of facet edges on so I can kind of see what I'm working with here. And I'm going to go right to the Mesh to Analytic tool and convert one of these cabinets into a solid. And I'll just leave all the default settings and go ahead and select the items, the components that I want to convert, and let the tool run on it. Let's go ahead and create the second cabinet next to it into a solid as well. Now let's go select some of the solids that were created and look at them a little bit further. And here you can see it, the cabinet base is now a nice well-formed solid, and we have where the drawers fit in a nice solid frame. In fact, if we zoom up and choose our chamfer tool, let's go ahead and confirm this is a nice watertight solid suitable for modeling operations by creating some chamfers on the edges. Next, we're going to go ahead and we're going to convert all of the cabinets in the file that are still meshes. And I've just box selected everything, and I'm letting the tool rip away on it. Now we're going to go ahead and isolate the meshes that did not convert. We did get over 150 solids to convert with our initial use of the command. The solids that didn't convert typically are meshes that are not closed. So let's go ahead and change our select mask to only select meshes and box everything and go to the show only command, and we'll see the two meshes that did not convert automatically. I'm going to go ahead and place those meshes in a layer so I can easily identify them relative to the other data. And I'll do that by selecting them and do a right select, change layer. Next, let's go ahead and show only one of the meshes that did not convert. And we're going to go over to the Mesh Analysis tool, PowerPack, and see what it tells us about this mesh. And we can see its volume is 0 and it has 25 open edges. So let's show those free edges, and you can see the part is open, and in fact those open edges form a planar mesh. So I'm going to go over and stitch this into a solid by first creating a cover surface of the open edges. Now let's go back to our layer manager and turn on the rest of the mesh that did not convert over. And what we're going to do is we're going to use our Mesh to Analytic tool to convert this into a surface. And to do that, we're going to uncheck the closed volume and then pick our mesh. And this time, the tool, you'll see that it works, but it converts it into a surface. Now, with the cover planar surface and the mesh we just converted, we can go and stitch this into a solid. And we'll confirm that it's a solid by going to the Verify Properties and just getting a mask properties associated with the object. In our next example, we're reading a native SketchUp file that contains a bunch of Lego parts. We're going to show how you can use the Combine tool to group together a collection of meshes into one to convert over into a solid. And we're also going to show how to use the Simplify options to convert into cylindrical faces. Let's zoom up on one of the pieces that we'd like to convert. And we're going to box select it, right click on top of it, and do a show only. Next, to see how many pieces we actually have here, I'm going to go to the PowerPack Utilities and Assorted Colors and box select everything, and you can see all the different mesh elements that compose this single Lego piece. So what we need to do is we need to combine all of these pieces into one mesh for our Mesh to Analytic tool to work. So we're going to combine everything together into one, which merges all the shared vertices. But I can see that the Lego is actually a separate mesh, so what I'm going to do is go to Separate All Parts, and that'll separate the Lego from the actual body that we're going to convert. Now let's go to PowerPack Mesh to Analytic, and using all the default options, let's convert this part over into a solid. As we inspect our part, we can see that the holes and the protrusions are faceted and not true cylinders. So what we're going to do is we're going to go over to the tolerance for converting curves in the Mesh to Analytic tool and change it to 0.01 and run it again and see if that gets the cylindrical faces. Nope, so let's undo it and let's change it to 0.02, apply again, and convert this part over into a solid. And this time you can see at this tolerance we get true cylindrical faces for our holes and our protrusions. And just to confirm that we do have a usable solid, let's go ahead and put a couple chamfers on some of these edges that were once SketchUp meshes. Next, we're going to go over the options for Mesh to the Analytic tool. Starting in the upper portion of the dialog box, we see our Curve Simplify tools. This includes options for converting circles, ellipses, splines, and the tolerance associated with that from a polyline. Next up are surface shapes. Surface shapes are the open, non-volumetric shapes, including planar and extruded surfaces. Following that, we have primitive shapes, spheres, blocks, cylinders, torus, ellipsoids, where the resulting shape actually has the parameters of the primitive, such as the torus has an inner and an outer radius associated with it. Next up are the extruded shapes, where the extruded shape will keep track of radius and diameters such that you can get your holes and fillets for your extruded shape. And then lastly, we have stitch shapes. A stitch shape has options whether you want to check for closed, whether you want to reduce the triangles into quads, to simplify the shape, and to validate the shape. Our last segment of our demonstration today is to go over some tips related to converting SketchUp files into analytical solids. Since SketchUp is not a solid modeler, some of the common issues you'll run across are due to the fact that it's not a closed, watertight volume. And this may be because there are open edges or there are non-manifold edges, where a non-manifold edge is when you have three faces sharing a common edge. Other issues consist of duplicated or collapsed or even overlapping facets in the original component. Now, there are some tools under PowerPack Mesh that allow you to start repairing some of these files to create a closed, valid, solid shape. And some of these useful tools are showing both free or non-manifold edges, closing holes, adding, deleting, and combining meshes, and the auto repair utility. Another interesting approach is to use our semi-automatic approach, where you take the component and you decompose it into its segmented analytical shapes. And those shapes that do not convert, you one by one go over and create and repair. Ultimately, you'll take these shapes and then stitch them into a nice watertight solid. Thanks for watching this video demonstration. For more information regarding ViaCAD or PowerPack, come visit us at www.masterviacad.com.